Good morning. All right, I still see that some folks are joining, but anyway, we have to start. So welcome to the third session of our series of technical workshops and demonstrations, which we call Tech Talks 4.0 on air. Welcome to those who are connecting for the first time. Welcome back to those who are connecting for not the first time. I'm Kirill Zhukov, so I'm with Extreme Networks, and I'll just give you a short housekeeping information on how to deal with that session. Today, in general, we're going to talk about Fabric Connect, so our flagship solution for building complex and small and big networks of any scale with high degree of automation and security built in. If you have any questions along the session, please utilize the Q&A panel. You can access it by pressing the button, which is called Q&A, in your Zoom client. And if you do so, the question along with the answer will be kept till the end of the session and will be sent out to you along with the slideware. If you want to ask a question in the chat window, okay, you can do that, but there is a chance that we will not be able to add that question into the Q&A report. So please use the Q&A panel. Just a few words on the previous session. So all the slides and all the Q&A reports have been sent out. So the Q&A report and the slideware from the previous session, which we ran last Thursday, was sent yesterday. Please double check your main boxes and double check the spam folders, because sometimes we receive some complaints that, oh, I didn't receive that. Please, can you resend it? Actually, we are keeping a track of everything, and we are pretty sure that our systems that sent out the emails are working fine. So please double check the spam folder. And even if you don't find it after that, please feel free to reach out to us and we will resend it over to you. Okay, so today's session is going to be brought to us by our systems engineers, Johnny Hermansen from Norway, and Emre Kurtman from the Czech Republic, and Adam Minowski from Poland. So guys, the floor is yours. Good luck.
Thank you, Kirill. And my name is, I said, Johnny Hermansen. Let me share my screen and move into presentation mode. So for those of you attending this session that is not familiar with the Extreme Fabric Connect, I will give you a brief overview of the solution. So Fabric Connect is based on shortest path bridging, which was ratified by IEEE as a standard back in March 2012 and published as the 802.1 AQ document. And some key people at that time identified it as one of the most significant enhancements in Ethernet's history. The standard was later moved into 802.1Q starting of 2014. And the whole idea was to address the growing complexity of computer networks. And so what they actually did was to replace all this, say, growing complexity, all these protocols like spanning tree and VLANs and OSPF and PIM and BGP and so on and so forth with one single protocol, ISIS. And ISIS was supposed to deliver and will actually deliver all the functions and features that all these, say, the traditional protocols were delivering. So the benefit of this is that you have something that is so much easier to understand. It's so much easier than to design your networks. It's so easier to deploy your network, to manage and operate your network, and to troubleshoot your network. But at the end of the day, we are actually building the computer networks to provide connectivity and services. So with the traditional protocol stack, also the services were layered on top of each other vertically, and there were also dependency between the different services. So for instance, multicast service depends on some layer 2 services and on routing services. So if routing fails, then your multicast services will fail. With Fabric Connect, on the other hand, the services are all at the same layer. And there's no horizontal dependency between the different services. So you could actually build a network that only provides IP multicast, and you could have many, many IP multicast services running on your network. Or you could build a network that deliver only layer 3 services or layer 2 services or any combination thereof. And also you can see on the far right side, there's also something called fabric attach. And my colleague Emre will discuss that in more detail afterwards. So how does this all work? So assume this fairly simple network is 6 switches. It could be any number of switches, and you can connect them in any way you like. The control plane will take care of the topology and will also ensure that the traffic is forwarded on the shortest path from source to destination. Hence, also the name shortest path bridging. And this network becomes like a network hypervisor. And on top of this network, then I deliver services and connectivity by creating virtual networks. And there's a couple of important things to notice here. We have actually a hierarchical Ethernet. I have the address space as we know it for my PC1 connected on the left side. I have the MAC address of the server. If I connect a firewall, anything I connect to this network will have its address space. And the network have its own address space. So as you can see, the switches have MAC addresses rather than IP addresses. So I can actually build my complete network without an IP address at all. So once I have built this say physical network, I have my network hypervisor, I can then start to deliver connectivity and services by creating virtual networks. And fundamentally, there are two types of virtual networks. I have a virtual layer 2 network, and this virtual layer 2 network is identified by a service ID, an ISID, which in my example is ISID 2001. As you can see on the left side, I have connected VLAN 20 to my virtual network, and on the right side, I have connected VLAN 10. So at the edge of the network, I still have my VLANs where I connect my devices, my host, my PCs, my servers, whatever. And also one important thing to notice, those VLANs doesn't have to be the same. As long as they are connected to the same service ID 2001, they are part of the same broadcast domain. And I can extend this broadcast domain to anywhere I like in my network. And then I can, instead of connecting VLANs to my service ID, my virtual network, I can connect virtual routers, VRFs, to my virtual networks. Then I have a layer 3 virtual network or an IP VPN, if you prefer to call it that. So how does this work? So I assume PC1 and server S1 are both connected to VLAN 20 as we see and VLAN 10. And my PC wants to send something to an application on server S1. So he will take whatever it is and put it into an Ethernet frame. And the destination MAC address of that Ethernet frame is the MAC address of the server. So he will forward this to the switch. The switch, knowing that this server is connected to VLAN 20 is mapped into IC 2001. He will encapsulate this into a new Ethernet frame, with the destination MAC address being the switch at the far right side where my server S1 is connected. This is like an ordinary Ethernet frame with a few exceptions. One key exception is this green field called ISID or service ID, which identify which virtual network does this packet actually belong to. But the packet will be switched to the network as an ordinary Ethernet frame, and eventually it will arrive at the far right side. And this switch will look at the service ID and identify this as a packet that belongs to VLAN 10. So he will strip out this outer Ethernet frame, and then he has the original Ethernet frame, and he will forward it to the server S1 that owns the MAC address 00222222. So in a nutshell, this is how Fabric Connect and SBB works. So to summarize this, we build a network and we deliver connectivity and services by creating a lot of over virtual networks. One is the IP shortcut network, which is purely for management and a bit outside of the scope for this presentation, but you can create as many virtual layer 2 network as you may need or want, and you create as many virtual layer 3 network as you may need or want. And then you can combine these in almost any way you like to create whatever type of service you need in your network. And then to support IP multicast, you just enable IP multicast at the edge of the network where your senders and receivers are located. So this ends my brief overview of Fabric Connect and shortest path bridging, and I hand it over to my colleague Emre, who will take you into the Fabric attached piece. Thank you.
Thank you, Johnny. So let me share my screen and hey, hello everyone. So I guess you can see my screen, right, guys? Okay, so
yeah.
I'm going to talk briefly about how Fabric Attach works and what is it. And then I'm going to hand it over to Adam for the main part of today's session and some advanced functionalities and use cases with a lot of demonstrations. So first of all, what is Fabric Attach? It's based on an IEEE standard. It's currently a draft standard. It's 822.1 QCJ called Auto Attach in the IEEE world. And it's in the progress of being standardized, and our PLM is heavily working on this one. So currently, even if it's not the standard, it's just a draft standard. There are a lot of third-party vendors that are supporting the auto attach functionality and Fabric Attach functionality. So let's have a look at how it works. Okay, so Johnny mentioned about how we can provision the services inside the SPB domain. But the Fabric Attach is more focusing on the automation in the edge part. So we have several different types of elements. The first one I would like to talk about the Fabric Attach server. It's also what we call the backbone edge bridge. It's basically the SPB capable nodes that are sitting in the let's say boundary of the SPB domain. Okay, so they are like the nodes communicating between the non-SPB world and the SPB world. Okay, so we have these as called Fabric Attach servers. And then we have the Fabric Attach proxies. And these are basically the access switches and our Exos and ERS families, they all support Fabric Attach capabilities. And one important thing to highlight is we are using LLDP communication as the control plane, and VLANs are being used as the data plane in this non-SPB part. So what happens when I attach a Fabric Attach proxy or an access layer switch to an FA server or to an SPB node? Assuming that I'm just taking it out of the box without any configuration, I just attach the switch to the SPB node, and then with the LLDP communication with the special type length values that we are sending from the FA server the management VLAN ID. Okay, first of all, and then Fabric Attach proxy, the access switch automatically assigns this VLAN ID as a trunk port and tags this VLAN. And also from the Fabric Attach server, this port is also automatically assigned as a trunk port Q tag. And one important thing to highlight is that the Fabric Attach server nodes, we don't need to create any local VLANs for the Fabric Attach VLAN. So no platform VLANs created. It's just automatically Q tag for this port. And then Fabric Attach proxy switch, I mean the access switch can automatically take its IP address from that management VLAN and is ready to be onboarded. So if you'd like to do further, let's say provisioning, then you can leverage Extreme Management Center and to do zero touch provisioning plus to add some more additional capabilities like span guard, adding, I don't know, IGMP swimming and that kind of preliminary configuration. So that's how initially Fabric Attach proxy is onboarded. And then, of course, we are attaching devices to the access switch, right? So we are attaching APs. In some cases, we are attaching Defender for IoT to protect IoT devices. We are attaching, obviously, wired connection to PCs, IP phones, printers. So there are two types of FA clients. So basically, one of them is the FA client. They are aware of this LLDP communication with the specific TLV. So they are aware of receiving the, for example, management VLAN and also signaling the ICID mappings back to the FA server. So these are called FA clients. And for example, if I take one AP and all the Wing APs and the APs from the campus controller, they support the Fabric Attach client capability. So as soon as I plug in my AP to a Fabric Attach proxy switch, Then this from the LLDP communication, also the AP receives its management VLAN ID, and this port is automatically tagged. And assuming that I have somewhere here my, let's say, XCA server or XCA controller or NXVX controllers. Sorry about my really horrible drawing, but after the management VLAN is assigned, the access point can communicate with its controller, because we are also sending the ISIT to the FA server. And then from the controller, assuming that you have several SSIDs, let's say the first SSID is a corporate SSID, and I'm assigning VLAN 20, and let's say ISIT 2000, okay? So I'm configuring this from the controller and sending back to the AP. And this VLAN is also automatically assigned as a tagged VLAN on this port, as well as on this port. So it's fully automated, as you can see, right from the FA server to the FA client and to the access point. So that leaves one final piece to the puzzle. These are non-FA devices. They are not aware of any of these communication. They cannot get the management VLAN or from that LLDP communication. They don't support those TLVs. And in this case, we are introducing extreme control into the picture. And in the fabric attach terminology, this is called fabric attach policy server. And we are using, for example, MAC authentication or .1x authentication. And once we plug in the IP phone, the PC, or the printer, and conduct the, let's say, authentication, the reduced server, in this case, extreme control, is sending the FA proxy switch, in this case, Exos or ERS switch, all the FA attributes. And with this fabric attach attributes, even if you don't have any VLAN globally created on the access switch, first it's automatically created, okay? And then it's assigned to this port, and it's tagged from the uplink port. And the ISIT, the specific ISIT, because we need the ISIT for the communication inside the SPV domain, it's also signaled back to the FA server. So this means a complete automation inside at the access part of our network. Okay.
Could I jump in, because I will show it in a minute. So well, it would be easier for me to show what you are just described. Yeah. So
definitely.
It will take it will make more obvious for people, I believe.
Definitely. So Adam will show this in his demonstration. So no worries if there are some, let's say, missing parts. Okay. So another important thing, as I mentioned, that we have also third-party ecosystem with the fabric attached. So you can see some industrial switches here, like Hirschman, Nexans, Microsense. They support fabric attached functionality. Also some IP camera vendors, they also support it, and with Open vSwitch. So it's not only extreme gear that supports fabric attached, it's also important to keep in mind. One last thing that I will mention, and then I'm going to hand it over to Adam. We also have a special, let's say, functionality called a fabric attached standalone proxy. In this case, in the picture, you don't see any FA server. So these are, this is more specific to the scenario where you don't have any SPV capable device in your network. So the core, the distribution, it might be a legacy network, or it might be a third party network that we don't have the Fabric Connect capabilities. In this case, you might still want to get use of the, let's say, VLAN automation at the access with the FA client and FA standalone proxy. Of course, the ISIT values will not be there, but you can automate and get ready for the migration of your core network. So that's it from my side, and then I'm going to hand it over to Adam for the DVR and the rest of the presentation.
Okay, then. Thank you, Emre. So when we are, after some introduction of some basic stuff, I would like to go with some more advanced thing, Well, the one of those things is the DVR, which is distributed virtual routing, and I will, you know, elaborate about the feature itself, and I will then show how it works live. Okay, so stick with us. Okay, so in general, distributed virtual routing, it's about, you know, because in mostly in data centers, we have the situation in which we need to assure the best traffic between east and west. Okay, so between the servers, because most of the traffic inside the data center is between the servers themselves. Yeah, we have the iSCSI storage, maybe the databases as well. Yeah, so in fact the traffic through north-south, so traffic from the clients to the servers is not so huge. Okay, so what we have here, yeah, so when we have two servers connected to one switch, it's kind of simple thing. Yeah, the servers can, you know, communicate between themselves. Yeah, and when we have the servers inside the same subnet or same VLAN, yeah, then we should go to the spine layer. Okay, so the traffic should go through the spine, which is, you know, this is normal in the CLO architecture. Okay, so but the problem, you know, just starts when we would like to go and pass the traffic between servers in different VLANs and different subnets. Yeah, then we should go to the router. Okay, and the router is in most cases is in the core, or, you know, some on some border leaf maybe layer or whatever. Okay, so this is the problem. And in fact, this kind of approach is good for the data centers which, you know, for the optimizing L2 traffic. Okay, but L3 is, well, it's a pain, I would say. So therefore we have the DVR. Okay, so what it is, in fact, the DVR stands for distributed virtual routing. It's the special feature inside the Fabric Connect solution, which can simplify the routing inside the data center, but not only in the data center. I will talk a bit about later. Okay, but what does it give? Okay, so the thing is that it can replace DVRP and RSMLT. RSMLT is well, also as well the Fabric feature. Okay, but well, if you have some third-party network, then most probably you are using the VRP for the L3 redundancy. Okay, and high availability. And it provides the host-based routing, which is kind of interesting, yeah, because, you know, each and every host will have its own /32 net mask and address and net mask pair. Okay, so this is the host-based routing, and it relies on the anycast. So each and every leaf in your server room, in your data center, will get virtual IP address. Okay, the virtual IP address will be, of course, the gateway IP address for the particular subnet. Okay, so in this case, you will get the first hop routing every time without any tromboning and anything like that. Okay, so and how it works, in fact. On this slide, you have the typical data center deployment model. When you have in fact, on this slide, there are two things which are really relevant. These are DVR controllers. Okay, so DVR controller is the place in which you will configure anything. Okay, so in this place, you just need to configure the VLANs, you need to configure the VRFs, virtual IPs and everything, the routing itself, okay? And on the DVR leaf, this is the second part of the DVR solution. So controller and the leaf, you know, just notice that I don't speak, you know, anything about that one, because it's irrelevant in this case. It's just, you know, just to assure the proper number of the ports, I believe, in data center to have some aggregation. But of course, these are the fabric switches as well. But DVR leaf, you know, what is the purpose? The DVR leaf gets all the information from the DVR controller, but it not gets like it is some kind of reconfigured by the DVR controller. It is it's about the control plane, okay? So it will create virtual interfaces on each and every leaf node with the virtual gateway IP. So in this case, you will get always fast hop routing. So your gateway will be on your nearest switch, and this is the beauty, okay? In fact, you can just, for example, because this one is really standard CLO infrastructure, okay, so architecture, but you can even interconnect all the switches like that, and you will have the traffic passing, you know, on the leaf layer all the time. So only the traffic to north-south, so from, for example, client here to the server here, it will go somewhere, you know, there, okay? So this is really nice thing. And well, but this is for the data center. I would not like to elaborate much about it. You know, if you would like to, I can do the presentation about the DVR only. But well, I spoke about the data center thing, but it can be used as well for different things. For example, this one, okay? So this is the example for the DVR working for the wireless roaming. I mean, the L3 roaming, okay? So you have some access points, you have the fabric network here, yeah? This is the fabric network, but here you have some standard network, yeah, with the fabric attached, for example, yeah, connected to the fabric. And then you can just move the clients between, and the client will not change the IP address, and it will have the nearest gateway, the nearest possible gateway, yeah, for the traffic. Okay, so let's go to the demo. And in fact, the things the Emre, you know, mentioned was just for the demo itself, because the demo looks like that. This is the map for the demo. I have some EXO switch here, which is traditional EXO switch. By the way, it's 670 G2. Yeah, and it is connected to the fabric here with fabric attached. I saw some question about this. Is it supported on this one, this particular EXO switch, the fabric attached, I mean? Yeah, this is supported, of course. And this switch is configured with fabric attached. We have DVR controllers, two controllers here. We have two leaves. And to make it even more complicated, we have two EXO switches here connected with fabric attached on those links. And we have two Linux machines connected to the network, okay? So what is the goal? So what I would like to show you, right now, this Linux is disconnected from the switch, okay? This one is connected. So I will show you in the control part, because if I will bring up the port, this Linux will show up on the port of this EXOS. The VLAN will be created. The VLAN will be added here on the trunk, yeah, here. And it will be signaled by the fabric attached that the VLAN should go to particular ISIT inside the data center. And the ISIT is connected, of course, with some VRF, and the VRF is configured on the DVR controller, okay? And then we can then have the traffic passing like that. And this is our router, which is, you know, our window to the rest of the world, okay? So, so this is the flow, more or less. And during the presentation as well, I will remove this link to show you the convergence, so how fast it is. I will run some MTR on the Linux machine to count the packet loss, okay? So I will do that, and as well, I will move this Linux to this switch from the vCenter, because those Linuxes are for on the virtual environment, okay? So I will move this Linux here, and you will show as well the packet loss on this Linux during the whole move, okay? Okay, so let me share first where I have it. I have it. Okay. Can you see the MOBA extern, Emre?
Yes.
Okay. So we have it. So let's go first on the exo switch, which is the exos, which is the edge exo switch on which I disabled the port, and I will show you that. I will show what I have here on the exo switch. Okay, let's make show VLAN. Okay, you can see I have only the default VLAN. The IT VLAN is the VLAN which is used for the management. This is the management IP, and of course, well, from the management VRF, some VLAN and some pre-out VLAN. Okay, I know that my Linux is connected right now. Well, it's physically connected, but I disabled the port. It's on the port 1. Okay, so let me show you what VLAN I have on the port 1. Okay, so you have only pre-out VLAN, which will be used for authentication of the machine inside the extreme control. So I will show you as well how it, you know, correlates with the extreme control. Okay, so let me check the neighbors. So yeah, I'm connected to VSP2 switch. And what else? Let me show you the VLAN, which is nice. The VLAN on the uplink port. Yeah, we can see here that we have the 27 of the trunk port. So the uplink port from the Exos to the VSP is 27. So yeah, we have only tagged IT. Okay, so let me go as well to the VSP2, because this is also interesting. Let me check the VLANs on the VSP2. VSP2 is a leaf, okay? DVR leaf. So let me show you the VLANs. Okay. As you might see, I don't have any VLAN here, okay? Show iSeed. I have 2 iSeeds already created by the DVR, okay? And some management iSeed, okay? So let me go back to the switch, and I will enable the port. Enable port 1. Okay, I need to switch to my extreme control. Okay. Okay, so this is the one. This is the Linux here. You can see it's connected to the proper switch on the first port, okay? And as well, it got the information that it should have iSeed 30 and, VLAN 30 and some iSeed, okay? I don't know, 200,030 or something, doesn't matter in fact. So I will then switch again to my to my shell. Okay, so let me show you the VLAN on the port 1. Yeah, I have VLAN here dynamically created. When I go show VLAN, you can see the VLAN 30 is created here automatically. Yeah, and you can see it on the uplink. Yeah, so let's go to the VSP. So you can see as well the assignment here on the uplink port on the VLAN 30 on this particular port is connected somehow, mapped to this IC. Okay, so in this way I can right now ping from this Linux, hopefully. Okay. Nice. Okay, so sorry for that. I need to change my window and go to the vSphere. Okay, I have two Linuxes here, so I would go to the web console. Okay, so this is the one. Okay, so you can see it have some IP address. I can then ping the gateway, which is the DVR. In fact, this is the virtual IP. Okay, so let's run the MTR and let's do it to the, for example, to the switch. Okay, this is the IP of the EXO switch on the as our gateway to the outside world. Yeah, so you have the packet loss here, and how many packets it receives and sent, and how many are dropped. Okay, so let me do it on the second machine as well, to the same IP. ifconfig, yeah, we have the machine in different VLAN, in different subnet, and MTR, this one, and that one, and okay. So the packet is sent each and every 200 milliseconds right now, okay? So, and, but, well, it's just let it run for some time. I will change it again here. And to show you how the DVR really works, it's like show DVR host entries, okay? And here on this screen, you can see, well, I got the different IP address here. So 3010, this is the first Linux, this is the second Linux, okay? So you can see that this one is connected to the VSP2, okay, here. And this one is connected to the VSP3. Why? Because the VSP3, you know, is, well, this is the another, the VSP, you remember the map. So, yeah, this is VSP3 here on the DVR leaf, and this is the VSP2, okay? So, let's go here. And let me do the following, okay? I will now, right now, you can see that the VSP3 from the VSP2, in fact, because I am on the VSP2, is reachable through the port 111, okay? So let me do that. Let me shut the port. So it should, you know, switch through the spine layer here, okay? When I go and shut it and go and show you the DVR host entries, yeah, you have the same IP like the destination IP on different ports. Yeah, this is kind of obvious because, you know, it just changes the traffic flow, and it did it immediately. Like I can show you how it looks like. Okay, so this is the Linux I just, you know, disabled the port. Okay, so this is the one change, and let me do another change. Okay, so the Linux 40 is running, and then I will change the switch. So I will put it on this switch fabric 1. Okay, fabric 1, go and go, and then let's go to the Linux. Okay, we have some drops because we have as well the authentication phase. Okay, if I would not configure the authentication, the time will be much quicker. Okay, but yeah, you can then just see that that I have it both right now. Yeah, 3011 is on the VSP2. Okay, so this is about it, about the demo. And let me go back to the slides. Okay. So I hope it was nice for you to see it in live, yeah, with the fabric attached as well. So let's go to another thing. I need to be quicker, I think. So let's go it quicker. Let's go quicker. So the thing is that right now we have the fabric extent. Yeah. So what is the fabric extent? Because, well, I showed you the DVR. Right now I will show you totally, you know, different feature, which is as well the part of the Fabric Connect solution. And, you know, I'm the big fan from the people who attended the last session, you know, notice that I'm a really big fan of, you know, the remote working. Okay, so this is the Fabric Extend purpose, more or less. Or the Fabric Extend is about how to connect the different place, so different I don't know, branch office, maybe your home, as it is in my case. In this case, I will show you how I will connect my home to the Fabric in Warsaw, in the lab which is located in Warsaw. Okay, so but back to the Fabric Extend itself. The concept is to have the possibility to spread the Fabric through some, I would say, not Ethernet links. Okay, by non-Ethernet I mean not physically directly connected Ethernet links. So it can be, well, you can imagine that it could be done through some tunneling. Okay, so this is the idea. So how to pass the Fabric traffic through the L3 connection, yeah, through the IP, in fact. And what does it give you? So yeah, this is kind of obvious. If you have some L3 network in your organization, then you can expand your network through your links, yeah? And you have some possibilities here, okay? You can do it through, of course, the MPLS, okay? We have many different MPLSs, MPLS protocols, or I don't know, techniques or whatever. Okay, we can do it through the VXLAN and IP with IPsec encapsulation or without. Okay, so this is one thing. We can do it through VPLS. We can do it through Ethernet LAN, like ELAN or E-line. So many different flavors of MPLS could be like the underlay for the Fabric Extend, I would say. Okay, so, and of course, we can as well do it through the normal IPsec, and I will show you how it looks like and how it works. And the main thing about the licensing, I forgot it during the DVR discussion. If you would like to run the DVR, you need to have the advanced license, okay? But only on controls. This is it. But if you have some other additional question, please do put it on the Q&A panel.
Yeah, it was already asked, Adam. So
okay, nice. Because I don't have the possibility to, you know, to follow the Q&A, you know, when I'm, you know, yeah, just trying to show everything, you know, smoothly. So, okay, so back to Fabric Extend. The Fabric Extend operates with the base license, and if you don't use more than 24 VRFs, it is included in base license. If you would go, if you would like to go with more than 24 VRFs, it's some kind of requirement that you need to have the premium license, and if you are using the L3 VSNs as well. Okay, so. But what is the most important thing to remember about the Fabric Extend here is the MTU. The MTU is really crucial for the Fabric in general, because Fabric is about, Fabric Connect is about encapsulation, okay? So no matter if we are doing the encapsulation like SPB, which is Mac in Mac, or we are adding additional encapsulation, then the MTU will rise. Okay, so the packet, the frame will be, you know, bigger and bigger, become bigger and bigger. Yeah, you have L2 normal frame tagged or untagged. You have then SPB frame, and you just need to encapsulate the SPB frame inside additional frame. So, for example, inside the VXLAN tunnel. And if you would like to use the IPsec, then inside the IPsec as well. So the VXLAN, so the frame should be as well encapsulated in IPsec. So please keep it in mind that the MTU is important. And if you are configuring, in fact, and if you would like to configure and play with it with Fabric Extend, and something doesn't work from whatever reason, you know, you think that it should work, but it does not. So please check an MTU thing. So this is the crucial thing. Yeah.
Adam, allow me to also make a comment here. So you showed the Fabric Extend over an IP-based network of some kind. It could be MPLS, it could be a private wide area network, but it's also an option if your wide area or MPLS gives you layer 2 services. We can do what we call backbone VLAN translation. So then we don't add any additional encapsulation to the SPB frame. So
yeah, I think I know I mentioned it's like that. Yeah, you can, of course, yeah, you can connect through the L3 and as well through L2. Yeah, L2 if you have the L2 connection between your sites. Yeah, through, I don't know, MPLS of whatever kind. Yeah, in fact, yeah, that's true. So again, additional next demo. So I just call it network distancing, which is like, you know, some kind of reference to the social distancing we have today because of the virus thing. And well, I don't have a virus, but I really like to work from my home. So right now, I will show you the flow of the demo. Okay. We have well-known part of the map of our lab in Warsaw. Everything here, which is mentioned like Fabric Network, is inside our lab in Warsaw. Okay, so everything here is in Warsaw. Okay, and here I have some services configured already, like. Here you can see the VLANs. I have some VLANs here at some of course example. Those three are examples. I have the IT VLAN, users VLAN, and guest VLAN. And well, what I need to do and what I will do with it. Okay, so here I have my home. I have quite normal router here in my home. And I have something which is called XA. Most probably you know or have noticed the product. So XA is a platform from Extreme which can connect connect you to the Fabric network and through IP. Yeah. So it does. So the MTU is really maybe not much important here, because the box itself is doing fragmentation reassembly thing as well. If for some people who remember the ONA adapter, it does the similar thing. So this is the box, yeah. And I have some Linux PC on my network as well. And then I will configure XA, maybe not from the scratch, but I will configure the tunnel here to have all my example services in Wrocław through the internet, in fact. Okay. So let me erase my drawings, beautiful ones, and let's go again to my terminal. Okay. I can close it. Then let's go to XA.
So now you are connected to the remote XA, right?
And I am connected here to my XA in Wrocław, okay, in my home, from which I'm doing the broadcast right now, in fact. Of course, I have, the additional connection to have the lab reachable through WAN or through the internet. I have additional tunnel, I would say, but, it doesn't matter. In fact, right now I need to show you how to configure the XA. Of course, in the Warsaw lab, I have the XA as well, and it is already configured. So I have the tunnel here configured, okay? But I can show you, for example, interfaces, and that I have it already configured. This is my internal IP address in Wrocław, okay? So maybe it will be, okay, because I will configure it. And I can show you ISIS interfaces. I have the XA in Warsaw connected to my VSP. In fact, VSP1 in this case, yeah, on port 11, and I have as well created a logical interface, which is L3 logical interface to Wrocław, okay? So you can see it's not up, it does not have any adjacency, I mean the ISIS adjacency. So the tunnel is not working, so let's go and configure. First, I need to configure I need to create VRF. Well, it is not required, but I'm doing it for the security reasons, of course. I will create the VRF, which is called FA for Fabric Extend, okay? So then I need to go and configure my interface, and my interface, local interface, is the interface gigabit 1/8. Then I need to assign the gigabit interface to the proper VRF I created, okay? And now the magical command, I have it prepared already, okay? So this is the magical command. It creates it configures the gigabit Ethernet port as a backbone router port, okay? you might probably notice that I have here a subnet. Well, I don't know why it is named like that, but in fact, I just here put the IP address. You remember in Warsaw site, I have it here configured like my another end of my tunnel. Yeah, so this is Warsaw, and let's switch to Wrocław. Yeah, I have it here. Okay, but I can show you also in Warsaw, show IP interfaces, VRF1. I have it, I name it differently here, the VRF, and here you have the public address of our XA in Warsaw. Yeah. So okay, so I configured the B router port. Okay, then I need to go and configure routing. I will do it like in one shot. Okay. So I need to go to context of the router, then of course IP route, and this is, as you might see, my internal the IP address of my router in home. Then let me check if it works. Okay, I need to, I should did I? This is good. It should work. My God. Okay. What could it be? Do I have my line Linux? Wait a second. Okay, yeah, I think it's, I know what I did. I know what I did wrong, in fact. How to...
Yeah, so while we're still looking into the trouble, so that's Kirill. We have
I have some problem with the mobile extreme, in fact.
Yeah, it's okay. It's okay. Take your time. So we have an interesting question, which is, do all these commands need to be done via CLI? Or is there a way of creating the same fabric extent via the fabric GUI? So Johnny Emmerich, can you comment on that?
Sorry, Kirill, I was busy answering another question. Can you repeat it?
Yeah, there is a very nice question. So we are looking at the configuration done via CLI, but is there a way of doing the same, configuring the fabric extend over the GUI, probably, which we have in the fabric manager?
Absolutely, Kirill. You can do it either using CLI or you can use Extreme Management Center to do the configuration. So, and eventually it will also be supported by our Cloud XIQ solution. So you have your choice.
Yeah, that's quite a nice one that we are going to port the configuration, the GUI side of the Extreme Cloud IQ as well, so that the whole fabric will be, so you will be able to configure many things inside the fabric through GUI in your Extreme Cloud.
This is also a lot about your preferences. So the fact of the matter is that, and it depends on the person. So it may look a bit complicated when Adam is doing his demonstration, but in reality, the number of commands you have to enter is so limited that's quite often you find it more convenient and quicker to do it using CLI than the GUI, but it's all about preferences.
Yeah, I'm pretty sure that there are always going to be some folks who will do that over CLI. Well, I personally, you know, I do trust CLI much better, just probably of my networking background with the CLI. But anyway, it's good that even in the cloud, you will be able to kind of control the fabric.
Allow me also to add that I think that is one of the beauty of Fabric Connect and shortest path bridging is the simplicity that really makes it so easy to understand and to then use CLI as a way to configure. But again, emphasizing the fact that yes, you have your choices. You can use GUI if you prefer.
Yeah, and just looking at the Q&A panel again, so we have started a conversation, I believe. So if we do it through a CLI and then you do some changes in the XMCPs of the Fabric Manager, so will the CLI commands be overridden?
To be precise, the Fabric provisioning, which is available on XMC, does not cover the full Fabric extend configuration part. So you can configure the services, but it's more it's more suitable for the scenario where you don't have Fabric extend. For Fabric extend, you might use the scripting and some workflows to automate that process. And in this case, it's not overwriting. So if you do something over CLI, it will be kept. If that answers your question.
I think it does. Yep.
Okay, guys, thank you. You know, I'm a bit nervous, you know, when I have the situation that something is not working, because you know I play with it.
Murphy is on the call, right? Again.
Well, I at least you know it's live. Yeah. So this is it. Okay, so then I configured the IP address for the B router. Yeah. So I need to check it in show interface as VRFFE. Show. You can see I'm a bit nervous right now, and I'm making mistakes. Sorry for that. VRFFE. Okay, so I have it already, and you can see I can ping Google, for example, here. Then I need to configure special settings inside the ISIS router. So I need to specify my IP address as the tunnel source address for the ISIS, and I need to specify the logical interface. The logical interface would be the interface to the Warsaw. Yeah, you can see that you have here the public IP address. Yeah. And then on the logical interface, you have to configure everything about the ISIS itself, and of course about the IPsec. So I will do it, you know, in one run. So forgive me, but I need to be quick. Okay, so this is it. So ISIS PBM1, which, you know, it creates, of course, the instance, or connects to the instance 1. I just set up the metric. I'm enabling ISIS. This is the preset key for the IPsec tunnel, and then I will create the IPsec tunnel. Okay, so it should come up. Okay, so I have it already up and adjacent. Yeah, so show ISIS adjacency. I have it. Yeah, this is Warsaw. So let's go to my Linux connected to it and run. You might see that I don't have IP address at all. So let's run DHCP. Oh, wait a second. I forgot something important because I don't have any ISIDs here. Okay, I didn't create it. So let's make some mapping. Okay, so let me check the VLANs. So I have the VLAN 111 and I will create it to the user's VLAN in Warsaw. Okay. Of course, I need to know the number, okay? So I just created the mapping in Wrocław, only in Wrocław, and then I would go here and run the HCP. Okay, so I got the IP address from Warsaw, and let me ping the same gateway I did during the last demo. Oh, sorry, this is not the one. This is the one. Okay. Okay. So right now from Wrocław, I'm pinging through the fabric to Warsaw. Okay. So sorry for the complications, but I think it was quite interesting to see it. Well, not my, problems, but how it works. Okay. So let's go back to the presentation thing and let's make it quick again. Okay. So just a quick thing about the securing fabric, because the fabric is secured by the segmentation, by many things, but in many people just forget that this is the Ethernet, of course, and it needs to be some kind of aware that it should be configured in some certain way. Okay. So let's then go to some basic stuff. I'm referring to basic stuff, but in fact, I'm naming it basic stuff, but in fact, those are not basic things. Like I have seen many times that many people just forget about it, okay? So just as a guideline, basic guideline, if you just deploy the Fabric Connect network, please limit the rates on the edge ports. Yeah, this is kind of baseline. Because we don't want to allow some storms through the fabric itself. Okay, fabric will gladly pass it through. Okay, so just keep it in mind. Use the VLACP for link integrity. This is the protocol used inside the fabric network for ensuring the integrity of the link. So it works somehow similar to the LACP, like the normal one, but the VLACP is only for the link integrity. There is nothing about aggregation thing. This is not a lag protocol, okay? So this is the thing. And please, please, please use SLPP, because SLPP is the protocol which prevents loops for being created on the access layer, okay? So please use SLPP, because Fabric will, I'm pretty sure, and I can assure you that the Fabric will, if the loop, if the loop appears on the access layer, then the Fabric will pass it through, okay? So your network will be affected. So please keep in mind, okay? As well, we spoke about the Fabric attach and the, well, we didn't spoke about the NNI ports, but the NNI ports and the communications between the nodes inside the Fabric can be protected with the some I would say the encryption or some keys for the communication between the nodes, like on the ISIS level. Okay, so ISIS packets can be somehow encrypted or signed with some key. So you should use it. You should use it in order to be sure that your devices are yours. Okay, Because if you just create the NNI port and you did nothing, then you can add and connect, I don't know, some rogue, even some rogue node, and then the attacker can have the communication to the whole fabric. Okay, so please keep it in mind. For the fabric attach, Emre just elaborated about the fabric attach, and I showed you how it works. So it is also possible because the fabric attach is the LLDP communication, so it is kind of open thing. Yeah. So Extreme created some security on this, on the top of this, and you can configure authentication on the fabric attach port. Okay, so you should do it from the fabric attach client or proxy side, and on the fabric attach server side as well. And in this case, you will be more secure because, you know, if someone just plug out the correct switch and then connect his own, then the fabric attach will not work if the guy, of course, don't know the password. Okay, so this is the thing. And the IPsec thing as well. You can protect the links with IPsec as well, but let's go to the MACsec thing. VOS switches and VSP switches are supporting the MACsec. Not all of them, but many of them. So just refer to some data sheets which one you can use in order to run the MACsec. But in fact, I have some demo. I don't know if it's okay to run it, but it should be quick.
It is okay, Adam. Yeah, we still have some time.
So the MACsec, inside the inside the fabric, you can have something which is called transparent UNI. Okay, transparent UNI is the type of UNI, so type of the connection through the fabric, which is some kind similar to pseudo wire. So pseudo wire, yeah. So if you connect something from one side, you can connect something from another side. Just create for, in this case, this is my demo example. Yeah, in this case, I will create the transparent UNI here and here. But what would it be for? In fact, the goal is to connect two EXO switches here through the MACsec, and this MACsec will be transferred through the fabric here. Okay, so this is the goal. So I would like to show you how flexible is the fabric in this case, and what should you do? What can you do with the fabric itself? Yeah. So this is the goal. So just to describe how the lab is constructed, I have two switches here, X670 and 450 G2s, and both of them have some special adapter connected to it. Okay, this is the adapter, MACsec/LRM adapter. Yeah, it is available. You can buy it, and it gives you some kind of retrofit, so you can add the MACsec to the Exos itself with this box. Okay, so let's go to the demo itself. Let's go to the demo. Let me close this one. And okay, so I need to open my two VSPs on which I need to create. I think I created it, but I will. Okay, this is really devilish, as you might see, devilish ISIT. it really doesn't matter what is the number. So let me go to this one. This is the X440 with MACsec adapter connected. And of course, the second end of the MACsec connection is already configured on the another EXO switch, okay? Because I don't want to go and configure both of them, so I have only one. So here you can see a MACsec status. So I don't have any ports in MACsec secured, okay? And ports, okay? So no MACsec connection, no nothing. So, but let me show you one interesting thing. Okay, you can see that I have the VSP as my neighbor. So this is the proof that I am connected to the VSP switch. Okay, so what I'm going to do right now, I will create, but okay, so first I will configure the MACsec on the EXO switch. Okay, so it's just a simple command, but let me check, show configuration MACsec. And let's configure it. I need to check as well. Let's wait a second. Let's wait a second. I will configure association on the ports. Okay. So, because this is some kind of secret password also, of course, but so I need to put it here. Okay. So right now I configured the MACsec association, okay, and it should show something, okay. Show MACsec, okay. I don't have any connectivity. Why? Because I didn't create it. I didn't create the transparent UNI on the VSP side. Okay, so it should be on the ports 28. It should be pending state. Okay, so it just tries to connect to the another switch. Okay, so let's go to the Exos switch. Okay, and let's configure transparent UNI. ISIT 666 Elon transparent. Okay, and I know what is the port. Okay, this is the first let's say side of the connection, and let's make another one. Of course, the ISIT have to be the same. Yeah, this is kind of obvious. And oh, sorry. Sorry. Oh my God. I forgot Elon transparent, of course. Yeah. So port 133. Okay. Okay. So show ISIT. Okay. So I have the Elon transparent here. And I can even show you ISIS, SPVM, ISIT all. And you can see that the Elon transparent is on the VSP upper and VSP lower. Okay, so let's go to the switch. Okay, we have ports secured, but who is the neighbor? You can see I pass all the traffic through the fabric itself. even I can see the neighbor on the another part of the link, okay, another side of the link. So this is about the demo of the MACsec. So let me show you one thing more. This is really nice use case. I think Johnny knows more about it.
We're seeing the presenter view.
Oh my God. Oh my God. Yeah, sorry for that. That's better.
Yeah, much better. Thank you.
Yeah. So this is even more sophisticated thing you can create, or you can achieve with the fabric itself. Here in this case, you have two VSPs, VSP A and B, and you have the MACsec between A and B, yeah, which is red one. And then, and for example, this one is the organization, for example, XYZ, yeah. And you have different organization here, like the green one, yeah. And the organization have the connection through, so the green organization have the connection through the red organization, okay? But they need to be secure, okay? So they don't trust the red organization, that the red organization is using the MACsec, for example, okay? But they are using, but it can be configured like in the easy way that it is possible to pass the MACsec between the VSP1 and 2 through the whole network, which is inside, again, protected by MACsec, okay? So it is kind of MACsec inside the MACsec thing. So it is really, really nice thing, but it's just, you know, I think, well, but in fact, it's not just for fun. This is the real life scenario when we have this kind of pilot, or I don't know, the implementation. But I cannot tell you where, in fact, because this is, as you can imagine, really, really secure network and the customer. And of course, don't forget about the basic thing. If you have to protect your network, then you can use ACL. But just at the end, yeah, this is the end almost. So inside the fabric, you can as well, with the ACLs, you can as well utilize the fabric and for creation of the airspan mirrors. Yeah, for example, if you have to put some traffic to your IDS monitoring, for example, or whatever reason it might be, yeah, you can use the mirroring through the fabric. So you can just configure on some, you know, BEB, some rule, and then you can, you know, take the mirrored traffic in anywhere you want, you know, inside your, or inside on the edge on your of your fabric, yeah. So you can pass the mirror traffic through the fabric in this way. So this is as well the good one, one good thing, you know, for you to play with, yeah. So that's about it. And just to summarize, you know, the Fabric Connect, you know, this is the most beautiful technology I have seen since ages, by the way. This is really simple. You can use it in any topology. You have one protocol. You don't have to have, or you don't have to use any, you know, sophisticated solutions like with SDN controllers or whatever. You know, it runs automatically. It gives you automation and everything out of the box, I would say. So you don't have to build any overlay. Of course, if you have some, then you can use it. It's fast in deployment, it's stable, resilient, and everything, you know. I really love it. So I hope you will love it as well. So with that, you know, I will end up my presentation. So thank you.
Okay. Thank you, Adam. Thank you, Johnny. Thank you, Emre. I think that was a great session. It was really, really extensive with a lot of technical knowledge and opportunity to learn. Just traditionally, a few words from myself to close the session. So on the Q&A side, I think that for the first time, we do not have any outstanding questions. So all of them have been answered. And as I promised, we will be sending out all the Q&A reports. So all the questions along with the answers will be sent out. So I will launch a quick poll. I kindly ask you to stay for another couple of minutes and answer the single question that will pop up, I hope. Okay, and in the meantime, I will start sharing just a couple of more slides. All right, so I see the answers are coming. Thank you very much for that. Regarding the next session, so as you probably know, we are continuing doing this on weekly basis. Okay, so next time we will meet in a week. This is going to be the 23rd of April at the same time, 10 a.m. CET, in the same place, the same Zoom connection. And we will talk about how to interconnect remote workforce. So probably this one is quite important right now. So what technologies are there to seamlessly and securely, with the help of some automation, connect the remote working people? And we will take a look at the things like Extreme Cloud IQ, and we will take a look at the solution which we call the software-defined wide area networking solution from Extreme. Just again, as a reminder, we do have a set of mini websites. So the one in English is en.extremenetworks.com. And we do have the Polish and Russian versions as well. So feel free to go there. There's a lot of localized and translated information over there. And at the same time, these are the exact places where you can find the access to all the recordings of all the sessions of this TAF Talk. So it's really, really worth going there and take a look at that. Okay, so I can see that the poll is somewhat ended, so we do have a lot of answers. Thank you very much for that, and thank you for investing your time for today's session. Stay tuned and see you next time. Stay safe, guys. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.
Thank you.